Hello, and in this tutorial or this video, we will go over meshing, how it works, and its relation to convergence. Now, of course, this is a very important topic as the mesh will make or break your CFD. More importantly, having inconsistent mesh will yield inconsistent results when you try to iterate your design. So having a consistent mesh and a usable mesh that converges every single time is extremely, extremely important. So let's first get into it. We have automated mesh. It's under operations. Let's go right into automated mesh. We have this. These are the properties. So first thing, never be on serial. Always be on parallel. You have your input parts, your tags, and this. Don't worry about that. But always be in parallel. It will always put you in serial first. Put it in parallel if you have more than one core. Now let's open this and let's go to measures. Now, we have selected, open that, surface mesher, automatic surface repair, trimmed cell mesher, and prism layer mesher. Essentially, this one, don't worry about it, just have it on, or don't have it on if you need surface repair. Usually it will run, and essentially it will pair things that are kind of broken, but most of the time, if they are truly broken, you will need to repair it in your CAD geometry, or in StarCAD, or just by moving stuff around. Surface remesher is for the surface mesher. Trimmed cell mesher is extremely important. It is for the volume itself, and prism layer mesher is all about the interface between the geometry and the volume around it. So let's try to understand these. I'm gonna open meshers. There are other select meshers. There are other meshers. If we deselect all these, you also have the option to do a polyhedral mesher or a tetrahedral mesher. I suggest none of these. Polyhedral mesher will, instead of being squares or cubes in the mesh, you will have octagons and stuff like that. It'll look different. It's not as good, and it takes up a lot of memory. Tetrahedral will have tetrahedrals. Essentially, that's just it. Trimmed will have our cubes. Surface mesher, automatic surface repair, prism layer mesher. So let's get into kind of these controls that come of this. So this base size is the first default control. This essentially does nothing. Change this value will only affect the other values if they reference them. So let's go to CAD projection. That's just protecting CAD. Target surface size. This is relative to the base. Essentially, it's referencing the base size as the target surface size for the entire domain. If we just put this to absolute, we change the base size, we don't change the target surface size. So essentially, everything, or almost everything, references this base size right here. And you'll see as we go through, everything will reference this base size. This is the correct way, or the more right way to do meshing, as if you have problems with convergence, or you just kind of change this number and you can get good convergence. And you can keep super consistent, and then you don't change anything else, you just change that one number, the base size. Now, let's get into the next thing, minimum surface size. This is the minimum size that essentially the mesh can hold. It is 12.5. Now, custom controls can override this, and as well as the maximum size, which is down here. But essentially, it's minimum size if you didn't have custom controls. Surface curvature. This is all about essentially points per circle. So essentially, how many more cells do we add on this curve? And now, as you can see, it's not on at all, but it is on in the custom controls that relate to airfoils and the mesh and other parts of the mesh. Surface proximity doesn't really do anything. Surface growth rate is the growth rate. So essentially, as you extend from very, very small meshing to large meshing, you have this growth. This refers to the surface, obviously, and it controls this growth from small to big to big to bigger to our kind of our domain size, which is out here. Auto repair, don't really worry about that. Now, this is where stuff gets kind of important. I will go over pretty much prism layers is extremely important. A lot of these are represented in custom controls instead of the entire domain. But essentially, prism layers is all about the interaction between the geometry and the volume. As I said earlier, prism layer measure. I will go over that more when I go over custom controls and how that works. I will go over these three later. This doesn't really matter. Volume growth rate is about the growth rate, but of the volume. And then maximum cell size will set the maximum, essentially. And now let's go into custom controls. Now, we have three types of custom controls. Volume, as they're here. Their inputs are volumes. Surfaces, their inputs are surfaces, as you can see. And curves, whose inputs are curved. Now, essentially, every volume control, essentially, if we go in here, you can control three measures. You can, if you want this certain volume to have the prism layer measures, you can import that, but every single surface in here has a different prism layer measure, so it's done in curve controls instead of just in volume, or that volume. So essentially, if you wanted to, the volume control, or to set a custom target size, and how you do that is obviously come here, you click this, you set your custom size relative to the base, which we can edit up here. Now, that's how, I didn't mean to close that, how all these volume controls work for detailed regions, just with different numbers, as you can see by the mesh itself. Now, secondly, is this curve control. This is actually not really all that needed, but it sets a target surface size and a minimum surface size that overrides these two up here. That's essentially what custom controls do. They override these numbers for certain areas like chassis, domain, yes, all this other stuff. Now, let's get into, I want to say, the meat of what we do is the curve controls, and there are a lot of them. Why there are a lot of them? First, let's go into this. There's this thing, only apply to contacting area. If this is clicked, we'll only apply these controls to the area and the contacting area. If this is not clicked, it will apply it to essentially the volume around the area, which is why you see prism layer measure being very different right here on the chassis versus right here in the corner. And let's just get into that right away. Let's just open up this chassis curve control. We have a target size, which is overrides target size 4, minimum. We have a curvature too. First, we have to enable this. We have a maximum point per circle, which is higher, and point per circle, max point per circle is higher. So essentially, per the amount of curves, we're going to have smaller mesh. And you can mess on these numbers, and you got different kind of. You see this here too. You have small number. You have more curves, more mesh. Essentially, what that does. Now let's go into, I guess, the entirety of prism layer, and it gives you these three. You can edit these three values. First is called number of prism layers. Now, essentially, prism layers are these right here. If you zoom in, these layers that are essentially attached to the geometry, attached. These layers essentially surround the geometry in its entirety. We can set how many we want. 10 is a good number. You want the interface between the volume and the geometry to be very smooth, and having more prism layers will allow you to get greater convergence and better results. So more prism layers is usually good. 10 to, I would say, lowest you would go is in 2D was 6. You could even go to 11, probably for, if you're going to do airfoils, I think this is 11 down here. I can look at that later. But essentially, this is a number of layers. You count them, one, you will count the number of layers here, it's 10. So let's go into prism layer near wall thickness. Essentially, this specifies the thickness near to the wall, and the layer is essentially being stretched based on this value. So how thick is this layer in terms of a wall? Now, of course, it explains it right here if you just look at where. number of layers, total prism layer thickness. Speaking of total prism layer thickness, here is what actually matters. This I'm sure does matter, but I don't really worry about that. This matters. We have this in absolute. Essentially, how thick is this? How thick can we make this layer so that the volume and the geometry kind of flow and don't have a lot of disturbance to the flow itself? Essentially, you want to make that transition from volume to not volume as smooth as possible as air goes around the geometry. Of course, let me open up one more. I'm going to go to a wing control, essentially. So let's go look at their prism values. Of course, here we go. We have 11 prism layers, and that would be wings to 4, would be probably around here. You count 11 flares here, layer thickness, and the absolute size of this layer right here, and then this other value that controls thickness. Essentially, those are all like the levers you can pull, and that's essentially what prism layer means up here. Now, as you can see, if you go to prism layers here, you have 1, which is why you have 1 layer here. Thickness is just very small, it's just this. Now, let me close this and talk about convergence and consistent CFD. Now, how to make consistent CFD is essentially never to do this once, you get good convergence with your geometry, to essentially never change it. If you iterate on that geometry, improve, or try to make it better, do not change the mesh at all. This is why the crisp penny mesh is really good. You just essentially plug it in, it gives you good results, and you just don't edit it, because if you edit it, you can have major problems. One of the major problems being that you will essentially get different results, different reports, different pressure. So if I were to run one simulation with this geometry with, we go up here, base size 30 versus base size 25, the simulation with the base size of 30 would actually make, or the reports would run, and they would say that you made more downforce if your base size was larger. However, the more you kind of lower this number, which is very interesting, if you lower this number to maybe 15 or 10, you just won't converge, because essentially it's too narrow, and it exposes the problems with your geometry to a point that it won't converge, and it'll keep glossing over two different types, two different results, essentially. So if you go into these, this is essentially straight. Now, if base size was too small, maybe 22, more mesh, more time, more memory you need to run it. But essentially what would happen is this would fluctuate up and down like a sine curve, essentially narrowing down on two different results. When you increase the base size, what are we doing? Let's go back to mesh. When you increase the base size, you can converge on one result, but that one result will have a more inflated results. So downforce will be more, drag will be more, and you will have greater low pressure versus high pressure on your car. So essentially building a mesh, creating a basis that you won't change is absolutely important to creating consistent CFD and getting consistent convergence. So that has been the video, and thank you for watching.